Déjà vu is the feeling that you've experienced something before. For example, you're in a bike race, you've just won, but you realize that you've won in exactly the same way before. Decimals have this experience all the time. For example, if we try to convert the fraction 1/7 into decimal form, we can do that through long division. Here we go. So, how do we proceed? Well, we have to figure out how many times 7 goes into 10, just once. Then we have to figure out the difference, 10 minus 7, that's 3. So how many times does 7 go into 30? That's 28, so 4 times. So subtracting 30 minus 28 is 2. And I can keep on going in this way, doing long division. Now, you might think that this is going to go on forever and ever and ever. And you would be right, because you can see that this is never going to get to 0. There's always going to be a remainder. And so it is going to continue forever. We end up with this enormous, ugly-looking decimal expansion. But look at the remainders that we've ended up with. First of all, we've got a remainder of 1 down here, 50 minus 49. We've got a remainder of 2 here, 30 minus 28. We've got a remainder of 3 here, 10 minus 7. Of 4, 60 minus 56. Of 5, 40 minus 35. And of 6, 20 minus 14. We've hit all of the remainders under 7. Are there any other remainders under 7? No. So the next number that we hit has to be a repeat. And indeed it is. It's a 3. Now it doesn't have to be a repeat from the start. It could have been a number midway through that list. But in this case, we're repeating the whole sequence. So we're again back at 30 minus 28. And then we'll again revisit 20 minus 14. So this is decimal déjà vu. So how does this pattern of remainders end up affecting our decimal? Well, it means that the decimal has to repeat. There's no other alternative. It has to repeat. And that's true of any integer divided by any other integer. You are always going to get a repetition. Now, the repetition might be zeros at some point. So, for example, 6 divided by 3 is 2.000000000. Yeah, okay? But it has to repeat. Now, let us think of a better way to write these decimals, because this is just looking too cumbersome, using too many trees. So we're going to simplify this. We're going to take that important part, and we're just going to put what's called a vinculum over it. And that's just going to say that that part is repeated. So 1/7 is equal to 0.142857, all repeated. Sometimes a little bit of magic happens with these decimal expansions. We end up with something called a cyclic number. You can Google it, but here is the cyclic number that we've just found by dividing 1 by 7. Do you notice something special about these products? Well, take a look at the one where we're multiplying our special number by 4. We end up with 1 4, 2, 8, 5, 7 just cycled. Isn't that a little bit of magic? And that's true of any one of those. Every integer fraction can be disguised as a repeating decimal. You should all be wondering, if the opposite is true, can every repeating decimal be disguised as an integer fraction? We're going to choose a particularly nasty-looking repeating decimal, 4.368. How on earth are we going to turn that into an integer fraction? Well, to try, we're going to try multiplying by 10. Are the 6's and 8's lined up? No. We're going to try multiplying by 100. Are the 6's and 8's lined up now? Yes, they are. So why don't we subtract those two? So we have 100a is equal to 436.86868686. And we've got a is equal to 4.368686868. Subtract the two. On the left-hand side, we get 99a. On the right-hand side, hey presto, the 8's and the 6's cancel. So we end up with 432.5. Now all we have to do is to multiply by 10, and we're going to get rid of that. So now we have integers on both sides. So a is equal to 4,325 divided by 990, which is good enough. Now I can simplify if I want, and the simplified form is 865 divided by 198. A similar process can be used on every repeating decimal. You can prove that to yourself, and therefore you have found a way to turn every repeating decimal into an integer fraction. Now it's time for a game. You're going to be adding fractions, much easier fractions than the horrendous nightmares that you've seen here. Sam has to be recalibrated by adding some oil to his innards. How much oil? Well, we have to get this ball bearing to float up here through this tube, and through this tube to be successful. So the amount of oil that I have to add here would be 0.75 minus 0.1. That would be 0.65. 0.65 plus 0.4 here. So that would be 1.05. And then plus another 0.15 here. So that would be 1.2 altogether. So I just zoom up here to 1.2 and add that oil. And I'm successful. Now let's say that I made a mistake and I try adding much too much oil. Oh, that didn't work well. And if I add too little, that also is unsuccessful. Enjoy.